Hi, my name is Amanda Bourne, and this is the spring 2025 semester. All right, here is the diagram of the eye. I'm going to start with the cornea. It is the outermost protective layer of our eye. It does have some curvature to it, which helps with the focal strength of our eye. The conjunctiva is going to be a thin membrane that coats the sclera, the outermost protective layer of our eye, and the inside of our eyelids. All right, so then we are going to have this area right here is going to be aqueous humor. This is a water-like substance that fills our eye. This substance actually is drained through the canal of Schlemm and the trabecular meshwork. When the aqueous humor goes through the canal of Schlemm, it is transported through the rest of our body, and it helps with maintaining our eye pressure. If the canal of Schlemm is not working properly, then we have eye pressure buildup, which can lead to glaucoma. The iris is the colored part of our eye. Typically you see blue, green, brown. It is what the color of someone's eye would be. The job of the iris is to control the size of the pupil. So if we are in a dark environment, the pupil is dilated, so more light can come in. If we're in a light environment, it's constricted, so not as much light can come in. We have the lens. So this is one of the major thing that focuses the light, and it is able to change curvature. It changes curvature through the ciliary body and the suspensory ligament. So these two structures work together to change the shape of the lens based on if we're looking at something close up or far away. If we're looking at something close, it is fatter. If we're looking at something far away, it is thinner. Next is going to be the posterior portion of the eye. We're going to start with the ora serrata. So this is where the retina ends and the choroid begins. So it's a small layer in between the choroid and the retina. The retina is the part of our eye where all our photoreceptors and the cones, the rods, all of that is located. So it is where vision starts to process. I colored it red in this picture. It is typically a reddish brown color. An interesting fact about this is that when you are taking a picture at night and you get red eyes from the flash, you are actually seeing the retina. So when you buy a camera or someone has a camera that reduces red eye, what happens is there's a flash first that causes the pupil to become smaller. So that way, during the second flash, not as much light is getting in to reflect off this retina. Therefore, it reduces the red eye. I thought that was very interesting. All right, so we have the sclera, which is the tough white outer protector of the eye. It is actually white when you look at an eye. And we have the vitreous fluid. It's a jelly-like substance that fills the eye, and it helps us with holding its shape. And it's directly behind the lens. Behind the retina and between the sclera, we have the choroid. The choroid is where all the blood vessels are that help with providing nourishment to the retina. We have our macula, which is this little, I don't want to say a pimple-like structure, but like little hill-looking structure. And then the macula is where most of our cone photoreceptors are, so our color vision. In the middle of the macula is the fovea centralis, and that one is going to be made up of almost entirely cones, and it's the only place where we have true 20/20 vision. Our optic disc is right here. It is a true blind spot, so we do not see anything right here, and it is the start of the optic nerve. The optic nerve leads out of the eye and into the occipital cortex, and that is where all these light impulses are turned into travel down the optic nerve and into the occipital cortex, where they become images.